Hello everyone. Thank you for the opportunity to present our study. My name is Ivana Crnčević and I conducted this research in collaboration with my mentor Nikola Marangunic. Today I will present our study on the relationship between emotional competence and mathematics achievement in primary education. As we know, students around the world face many challenges during their development. And in school contexts, many experience difficulties in coping with academic stress and anxiety. This creates space for innovative learning approaches that emphasize not only cognitive skills, but also emotional intelligence and its development. Although emotional intelligence is highly valued, its application in mathematics education remains limited, partly due to insufficient teacher education and the strong focus of curricula on cognitive and analytical skills. Mathematics anxiety, defined as feelings of tension, apprehension, or fear that interfere with performance, has been shown to negatively affect mathematical achievement and problem-solving strategies. Research further emphasizes the importance of emotional safety and a positive classroom climate, suggesting that emotional competencies are important predictors of both well-being and academic effectiveness. Emotional intelligence is described as the ability to recognize the meaning of emotions and the relationships between them, as well as the ability to reason and solve problems based on emotions. Over the past decades, different theoretical models have conceptualized emotional intelligence in different ways. Meyer and Salovey describe it primarily as a cognitive ability, while Goldman views it as a set of personal and social competencies. Emotional intelligence includes the ability to recognize, understand, express, and regulate emotions, and to use them in decision making and reasoning. The development of these theoretical models has led to numerous empirical studies confirming the importance of emotional intelligence in educational contexts. In primary education, it also plays a preventive role in later mental health difficulties. Recent school-based intervention programs have shown promising results in fostering emotional skills, although emotional education is still not sufficiently integrated into teacher education programs. Given the influence of emotional competencies on learning and school functioning, understanding emotions within specific subjects such as mathematics becomes particularly important. Mathematics anxiety is a psychological state characterized by feelings of fear, tension, and apprehension in relation to mathematics. While occasional anxiety may be common when solving complex tasks, students with mathematics anxiety may experience stress even in everyday mathematical situations. Research indicates that mathematics anxiety has a strong negative impact on achievement and students' attitudes toward mathematics. One of its most significant effects relates to the reduction of working memory capacity. In stressful situations, anxious students have greater difficulty retaining information, which limits their ability to engage in logical reasoning. Importantly, mathematics anxiety develops within the classroom context. Emotional climate, social relationships, teaching style, and overall psychological atmosphere all play a role. Teachers can contribute to reducing mathematics anxiety through supportive instructional practices and systematic emotional support. Collaborative learning empowers students to engage with real-life problems, collaborate with peers, and develop critical thinking skills. In mathematics education, it has been shown to improve the understanding of mathematical principles through hands-on and interactive activities. Research also confirms a relationship between group work and the development of emotional competencies. However, successful implementation depends on factors such as students' motivation and teachers' awareness and competencies. In line with these findings, the aim of the study was to examine the impact of structured group work on the emotional development and academic achievement of sixth-grade primary school students. The aim of this research was to determine whether there are differences in the level of emotional intelligence of sixth-grade primary school students before and after an intervention that involved changes in teaching methods in mathematics instruction. The intervention included more frequent use of group work and project-based tasks during the instructional units triangle and quadrilateral. In addition, the study aimed to examine whether the level of emotional intelligence influences students' academic achievement in mathematics. Based on these aims, 3 research questions were formulated. First, whether there are differences in emotional intelligence before and after the intervention. Second, whether students in the experimental group demonstrate a higher level of emotional intelligence after the intervention compared to the control group. And third, whether the level of emotional intelligence is positively associated with students' academic achievement in mathematics. For data collection, 4 instruments were used. The first was the Emotional Competence Questionnaire for Children, known as UEKD, which measures 3 dimensions of emotional competence. Additionally, 5 items assessing attitudes toward a group were included. The second instrument was the Mathematics Skills Assessment Test, consisting of 15 tasks assessing mathematical knowledge and logical reasoning. In addition, students completed written assessment from the triangle and quadrilaterals units. The study was conducted in 2 phases. In the first phase, during the instructional unit on triangles, Class 6A formed the experimental group, referred to as ESA, while Class 6B formed the control group, referred to as KSB. Students completed the Emotional Competence Questionnaire for Children and the Mathematics Skills Assessment Test before the intervention. The intervention included structured group work during lessons and 1 project task. After the intervention, students completed again the UEKD questionnaire and took a written assessment related to the triangle unit. In the second phase, during the instructional unit on quadrilaterals, the roles were reversed. Class 6A became the control group, referred to as KSA, and Class 6B became the experimental group, referred to as ESB. The intervention was implemented in the same way as in the first phase. At the end of the study, both groups again completed the UEKD questionnaire and took a written assessment of educational outcomes from the quadrilaterals unit. The participants were students from Class 6A, consisting of 14 students, and Class 6B, consisting of 18 students. The study was conducted during 2 instructional units, triangles, which lasted 15 class periods, and quadrilaterals, which lasted 12 class periods. Participants' identities were fully protected. To ensure comparability between groups, a pre-test consisting of 15 tasks from different mathematical areas was constructed. The Cronbach's alpha coefficient was 0.328, indicating low internal consistency. This suggests the need for further psychometric refinement in future research. However, the test served primarily as a basic orientation tool regarding students' prior knowledge, rather than as a standardized measurement instrument. For the UEKD questionnaire, reliability coefficients were very good or good across all 3 measurement occasions, with Cronbach's alpha values of 0.844, 0.797, and 0.823. The collected data were processed using the SPSS statistical software package. Descriptive statistics of the mathematics skills pre-test indicate that students in both groups achieved similar results in terms of prior mathematical knowledge. The experimental group achieved an average score of 10.50 points, while the control group achieved 10.94 points. A Mann-Whitney U test confirmed that there was no statistically significant difference between the groups at the beginning of the study, meaning that the groups were equivalent prior to the intervention. The reliability of the UEKD questionnaire was high, with a Cronbach's alpha of 0.844. When examining initial differences in emotional competence, a statistically significant difference was found only for the component expression and regulation of emotions, where the control group had higher ranks. For the other components, perception and understanding of emotions, regulation and management of emotions, and attitudes toward group work, no statistically significant differences were found. Due to the initial differences in the component expression and regulation of emotions, This component was excluded from further analysis of the intervention effect. To determine the effect of the intervention, post-test differences between the experimental group and the control group were analyzed for two UEKD subscales. The reliability of the UEKD questionnaire after the intervention was 0.797, indicating good internal consistency. Descriptive statistics show that mean values for emotional competence components were slightly higher in the control group. A larger difference was observed in attitudes toward group work, where the control group had a higher mean score compared to the experimental group. The Mann-Whitney U-tests revealed that a statistically significant difference was found only for attitudes toward group work, with students in the control group expressing significantly more positive attitudes. For the components perception and understanding of emotions, and regulation and management of emotions, no statistically significant differences were found. These findings indicate that the intervention had a specific effect on the perception of group work but didn't lead to the statistically significant change in the measured emotional competencies in the post-test. Within the experimental group, changes were analyzed using the Wilcoxon-signed rank test for the components related to emotional competence, perception and understanding of emotions, as well as regulation and management of emotions. No statistically significant changes were found after the intervention. However, statistically significant change was observed in students' attitudes toward group work. The results indicated that while the intervention did not produce measurable changes in emotional competence within this phase, it did influence how students perceived group work, as demonstrated in this graph. In the second phase, Class 6B served as the experimental group. The reliability of the UEKD questionnaire remained high. The pre-test comparison using the Wilcoxon test showed no statistically significant differences for any of the components. Therefore, the intervention did not produce significant changes in emotional competence or attitudes toward group work in this phase. To examine whether emotional competence is associated with students' mathematics achievement, a Spearman rank order correlation analysis was conducted between the final UEKD scores and the final mathematics grade. The analysis revealed a moderate, positive, and statistically significant correlation. This indicates that students with higher levels of emotional competence achieved higher grades in mathematics. The results of the first phase confirmed that the experimental and control groups were relatively equivalent at the beginning of the study. After the intervention, no statistically significant differences were found in emotional competence between the groups. However, a significant difference was observed in attitudes toward group work in favor of the control group. Within the experimental group, no significant changes in emotional competence were detected, but a significant decline in attitudes toward group work was found. This may suggest a possible saturation effect due to repeated implementation of group activities. In the second phase, again, no statistically significant changes were observed in emotional competence or in attitudes toward group work. These findings indicate that group work, when used as a dominant instructional method, may not be sufficient on its own to foster emotional development and may even lead to resistance if implemented too frequently. At the same time, a moderate, positive, and statistically significant correlation was found between emotional competence and mathematics achievement. This suggests that higher emotional competence may be associated with higher academic success. Overall, although the intervention did not increase emotional competence, it clearly influenced students' perception of group work and highlights the need for a more thoughtful and balanced integration of collaborative learning into teaching practice. Although the study was conducted systematically, several limitations should be acknowledged. First, the duration of the intervention was relatively short. Emotional competencies develop over time through continuous practice and reflection, and several weeks of intensified group work may not be sufficient to produce measurable changes. A follow-up measurement 6 months after the intervention is planned in order to explore possible delayed effects. Second, the sample size were relatively small and included students from only 2 classes within a single primary school, which limits the generalization of the findings. Third, group work does not suit all students equally. For some students, frequent collaborative activities may cause stress and reduced motivation, which may influence attitudes toward this form of instruction. Finally, although the instruments used were previously validated, they may not be sufficiently sensitive to detect short-term changes in emotional competence. Despite this limitation, the study provides valuable insights and directions for future research. Thank you very much for your attention. I will be happy to answer any questions.